What if I told you that right now, an entire civilization of underground architects is disappearing? Not with a bang, but in complete silence. Picture this. Deep beneath the sun-baked soils of Africa, there exists a world of intricate tunnels, hidden chambers, and secret passageways. This isn't some ancient ruin. It's the work of African skinks, small lizards that have spent millions of years engineering one of the most complex underground habitats on Earth. But today, that world is collapsing. Not because of predators or disease, but because the very ground beneath them is being stripped away. And what's happening to them reveals something much bigger about how we're changing the planet. These aren't just lizards digging random holes. They're ecosystem engineers. Each species of skink creates a specific type of burrow. Some build vertical shafts that act like natural wells, others dig horizontal corridors that aerate the soil. Together, they create a hidden city underground that supports countless other species. Insects, fungi, even plant roots follow their tunnels. But when the skinks disappear, that entire underground network collapses. So how did we get here? To understand why skinks are so vulnerable, we need to look at what makes their world so special. And so fragile for millions of years, African skinks evolved in some of the most stable environments on the continent. Unlike surface-dwelling animals that can migrate or adapt quickly, skinks are deeply tied to their specific patch of Earth. Their burrows maintain precise humidity levels, temperature ranges, and even chemical balances in the soil. Some species spend their entire lives within just a few square meters, generations of skinks living in the same tunnel systems, maintaining them, expanding them. They know every turn, every chamber, every escape route, but stability became their Achilles heel. Because when modern agriculture arrived, followed by urbanization and mining, these ancient soil structures were the first to go. The problem isn't just that skinks lose their homes, it's that the very composition of the earth changes. Compacted soils from heavy machinery, chemical runoff from farms, and erosion from deforestation alter the ground in ways that make it impossible for skinks to rebuild. They can't just dig new burrows elsewhere. The soil has to be just right. Too sandy and tunnels collapse. Too clay-heavy and they can't dig. Too dry and their skin can't breathe. Now let's look at what's happening on the ground, literally. In regions like the succulent Karoo in South Africa, where skink diversity is incredibly high, habitat destruction is happening at an alarming rate. Farmland expansion turns rich, complex soils into monoculture fields. Mining operations scrape away entire layers of earth. Urban development paves over the ground entirely. In each case, the destruction is total. There's no damaged but recoverable habitat. Once the soil structure is gone, it's gone for centuries. But here's what makes the skink crisis particularly alarming. Their disappearance creates a domino effect underground. Take the giant legless skink, a remarkable creature that looks more like a snake than a lizard. It specializes in hunting insects deep within the soil. When its burrows are destroyed, those insect populations explode, damaging plant roots and altering soil chemistry. Without the skink's tunnels, water can't penetrate properly, leading to increased runoff and erosion. What begins as the loss of one species ends up destabilizing the entire substrate. Then there's the sandfish skink, an incredible animal that can literally swim through sand. It creates fluid, shifting tunnels that help maintain desert ecosystems. When these skinks vanish, the sand becomes compacted, less able to support the specialized plants and animals that depend on that unique environment. Entire microhabitats disappear. What's perhaps most heartbreaking is how quietly this is happening. While conservation efforts often focus on charismatic megafauna, elephants, rhinos, big cats, the skinks are vanishing without notice. No dramatic footage of their last moments, no public outcry, just the gradual silencing of an entire underground world. Researchers are finding that some skink species have disappeared from over 80% of their historical range, many before we even fully understood their role in the ecosystem. But there is hope emerging from unexpected places. In Kenya, conservationists are working with farmers to create skink corridors, strips of untouched land between fields where soil structure remains intact. In Madagascar, researchers have developed artificial burrow systems that can help skinks survive in partially disturbed habitats. And in South Africa, some mining companies are now required to carefully remove and preserve topsoil before operations begin, then replace it afterward, giving skinks a fighting chance to recolonize. The most promising development comes from community-led conservation. Local farmers are being taught to recognize skink burrows and protect them. In return, they benefit from healthier soils that require less fertilizer and retain more water. It turns out that what's good for skinks is often good for agriculture too. This creates a powerful incentive to protect these underground engineers. What we're learning from the skink crisis is that conservation isn't just about saving individual species. It's about preserving the intricate relationships that hold ecosystems together. The skinks taught us that sometimes the most important conservation work happens not in sweeping landscapes, but in the quiet, dark world beneath our feet. When we lose these underground architects, we're not just losing lizards. We're losing living libraries of soil knowledge, animals that have perfected the art of building stable environments over millions of years. And in a world facing desertification and soil degradation, that knowledge might be more valuable than we ever imagined. Have you ever encountered an animal that completely changed how you see an ecosystem? Share your story in the comments. We might feature it in our next exploration of Earth's hidden worlds.